Thank you. So just before we had a talk with no code at all, and to balance it out, I'm going to do a talk with all code now. It's going to be 100%. So yeah, my talk is about self-sizing cells. And for those that don't know, I think there's a few people pretty young in the audience. Self-sizing cells were introduced back in iOS 8, I believe, right? Before that, before they were introduced, you had to calculate your rows heights manually. You had to either use a magic constant, or you had to calculate label heights like an animal or anything like that. Like, it's really something fairly fresh and new in iOS world. And like anything that's fresh and new or kind of magic, well, on the first year it was released, it was pretty buggy and it was slow and people didn't understand it. And in a way, over the years, it never got really that much better. And so people are still prejudiced to this day about self-sizing cells. So my talk is about basically talking about them, how they work, and maybe you can gain a better insight as to how to use them and troubleshoot them if you have problems in your own apps. But before I begin, I just want to quickly talk about the auto layout basics, right? For those who don't know, auto layout is a holistic layout engine where it takes into account all the constraints you define into your view hierarchy and tries to solve them. Every constraint is basically a linear equation of the form A is equal to bx plus y. And the unknown variables in these equations are all your views, origin, x, y, width, and height. It tries to solve all of that all together. That's simply what auto layout is. It is a constraint solver trying to solve a bunch of equations. Your equations just try to calculate views frames. Anyway, so in order to try to understand self-sizing cells, I wrote this app, this really simple app that I call Footy, and you will see what it does. So I'm just going to run it. It's not very functional. It's really basic. The point is really to try to start playing with it and start to see what happens. So this app is a simple table view over the full screen. It just lists all the AFL teams in the Premier League here in Australia, because we're in Australia, and so that helps me figure out that Western Bulldogs, for example, are not on the western coast of Australia. Actually, they're in Victoria. So very straightforward, very simple app, just a simple table, right? And we're going to start playing with that and really use that as a playground. But before I continue, I want to know, considering the screen, I think, can anybody see the font right now? Or do I have to increase it? Yeah, I probably have to increase it, right? So tell me when it's good. Okay, we're good now? Okay, great. So you have seen the app, and now let me just show you the layout of my cell. So I'm going to open the storyboard for that, which is main. So let's wait for Interface Builder to load up. And you can see I only have one prototype cell. I have an image view on the left, a label on the right. Everything is pretty straightforward. And basically, these two views right next to each other are laid out so that they are centered on the y-axis. And here you can see that there's a greater than or equal constant to be sure that it's under the top of the content view of the cell. And there's a lesser than or equal to be sure that it's under the bottom of the content view of the cell. Interface Builder has a bug right now where it shows a greater than, but it's really a lesser than. So there's nothing wrong with this layout. It's a perfectly valid layout. It makes sure that everything that I have in the cell is centered and that the cell grows with its content. And I can validate that. I could have used, by the way, a stack view here, but just for demonstration purposes, I wanted to keep the set of constraints really simple. So, and I can show you that everything behaves as I expect. So if I use this tool that you may know already, which is called Accessibility Inspector, which allows you to introspect and investigate how your app is behaving as far as accessibility is concerned, you can basically select an iOS simulator like here, and then you can go in this pane all the way to the right. And you can dynamically change the dynamic type that a user may select on their device. And you can do that while the simulator is running, which is really useful. So you can see that I can increase the font of my app. And yes, my cells are resizing. They are resizing to fit the content. Everything is working as expected. So like I said, I'm just demonstrating that my app behaves like I want. So I'm ready to ship that on the App Store, but that's not really the point right now, right? The point here, we are here to understand how self-sizing works. So I've got an ID. And if I go back to my cell class, oh, what's happening? Okay, I'm in storyboard, that's why. Oh, yes. This is my cell class, and obviously it has just two simple things, which has two basic outlets. You have seen the layout. What if I just created conflicting constraints and see what happens if I do that? And maybe that will tell me a bit more about self-sizing. So I'm going to do just that, and I've got this snippet of code that I'm just going to paste in, which enables two constraints. So we have two constraints. One says that the logo view needs to be, the height of the logo view needs to be equal to 1. And then another one that says that the height of the logo view should be equal to 2. So clearly conflicting constraints. There's no ambiguity here. This is an unsatisfiable layout. And let's see what happens if I run this. So my app is restarting. Oop, and that was, sorry, I'm just, forget you saw that, and I'm going to restart this. There you go. There you go. I'm launching the app, and everything is broken. You can clearly see that the conflicting constraints have broken my layout, and things don't appear as I expect. But I've got something very interesting that happened as well in the console right behind. I've got UIKit basically yelling at me that it cannot satisfy these two constraints. That's what I expected. I'm not surprised. It's basically telling me that these two constraints I defined are not satisfiable. Everything is expected. But there's also another thing all the way at the bottom, which is very interesting, which is it tells me to make a symbolic breakpoint at UIViewAlert for unsatisfiable constraints to catch this in a debugger. And I want to know right now in the audience, who has done that already? Who has followed that advice? I see a few hands, but more than half of the room basically has never done that. So I'm just going to follow what UIKit is telling me. I'm just going to break on that breakpoint, and let's see what happens, right? So I'm going to capture that, and I'm going to add a symbolic breakpoint. So I go here, and I copy that symbol. And I paste it in, there you go. And we can see that the breakpoint has taken, there's indeed a symbol that exists in UIKit core that defines this. And I'm going to rerun my app, so I'm going to restart it right now. There you go. And let's see what happens. And we have hit the breakpoint. So indeed something has happened, and what I've been told to break on has activated, which is great news because I can start trying to understand what's going on. So I'm going to increase the width of that thing, and I'm going to zoom in, don't worry. So let's inspect the backtrace. I love looking at backtraces. They tell me a lot about how things work and what systems are working right now. And if I look at the top of it, I've got, first of all, this giant method name, which is NSIS engine handle unsatisfiable row using invisibility and link behavior prospective row head mutually exclusive constraints. Whew, it's quite a mouthful. But basically what's telling me is that this is the layout engine doing its work, right? This I can assume from the name of the selector that this is a layout engine trying to solve the equations. Everything in that backtrace, at least at the top, is telling me like it's trying to solve these equations and it's not satisfying these constraints. That's one of the great things about iOS, right? Is that all the frameworks, or most of the frameworks, are written in Objective-C, which means that we can see the selector names for all of these methods. And Apple selector names are usually pretty descriptive. We can understand what system is being we are going through in order to see what's going on. So anyway, at the top of this backtrace, I can really see that we are dealing with the layout engine. So far so good. That's what I expect. I'm going to go down below. There's some UI view category that's called UI constraint based layout. Once again, everything looks all right. Everything looks like I expect. And then I continue below, and here I see like, oh, I've got my actual method, cell update constraint. This is the method I just implemented. So yes, we are going through that, and as I inject my invalid constraints, the auto layout engine is screaming at me. Once again, everything is expected. But if I continue down below, and I'm going to zoom out and zoom back in, I can see again some constraint code and constraint logic applying. And if I go down below, I can see, oh, there's something very interesting here. There's UITableView height for cell at index path underscored because it's a private API. And so clearly we are in the path right now where UITableView is trying to size its cells. And right above that, I've got something very interesting. I've got UITableViewCell, system layout size fitting size with horizontal fitting priority, vertical fitting priority being called. And that's really interesting because that's telling me that UITableView is using this method to size its cells. And this method, for those who don't know, is a public API. It's available on UIView. This is something you can use yourself. So UITableView is not using anything hidden. It is using an API that you yourself may be able to use. And you may already have used it actually in your own projects. But that gives me an idea, right? That gives me an idea, which is that why don't I just override that method in my set class? Because it's a public API, I am allowed to override it and basically see what happens in that case. So I'm going to go back, I'm going to crunch that back, go back into my cell implementation, and I'm going to override system layout size, fitting size. I don't need these conflicting constraints anymore, so I'm going to remove this because I got enough insight from using that. But I just overrode system layout size, fitting size. And you can see it's a method that takes a target size and then two UI layout priorities, one for the horizontal axis and one for the vertical axis. So let's see what it does, right? All I'm doing in my implementation is calling the super implementation of that method and returning the result. So I'm not changing any of the behavior. I'm just making it so that I can break and I can investigate what arguments I pass to this function and maybe what the result is going to be. So let me execute that function again, my app again. And there you go, we broke on that function exactly where I expected it to be, right? We are currently executing hide for cell at index path. And it is indeed calling that big method that I'm not going to reiterate the name of because it's quite a mouthful. But yeah, let's investigate what parameters, what arguments are passed to that function. I'm going to open that little inspector here, and we're going to see exactly what's being passed. There you go. So the first argument is called target size, and we can see that it's a CG size where the width is 414. 414 being the width of an iPhone XR, which is what I'm using as a simulator right now, and a height of 0. So okay, let's see. And the horizontal fitting priority is equal to 1000. So for those that would probably already know that 1000 is equal to priority required. Vertical fitting priority is equal to 50. And I can tell you that this matches to a fitting size level, I believe, as a constant name fitting size level for that specific value of the priority. And our result here of that call is equal to 414 and the height is equal to 46.5. So what happened here? Well, I'm not going to open the documentation for system layout size, fitting size, but really it makes perfect sense. What UITableView does is that, before I even explain to you, I lied to you basically. I lied to you when I showed you my cell layout. My cell layout that I showed you is actually, I told you it was not ambiguous and it was satisfiable. In truth, it was ambiguous, right? If you think about it, there are multiple solutions to that set of equations. So the obvious one is that my cell is as small as possible on the y-axis, right? It hugs its contents. That's what you expect to see on screen. But there's actually perfectly overvalid values that satisfy this layout. My cell could be 100 points tall, and my equations would still be satisfied. My cell could be 1000 points tall, it would still be satisfied. This layout in my cell was ambiguous, but Interface Builder didn't complain. And why is it? Because Interface Builder knew that there would be a pass where UITableView tells my cell, okay, what size would you be if I constrain you to my width? Because a UITableView is basically scrolling on the vertical axis, right? What if the width was fixed to my width? And what if you were as small as possible? So what system layout size, fitting size does is that it creates a temporary layout engine and introduces two temporary constraints into the constraint system, two new equations to solve the whole set with. It introduces one where it's going to say, I want your width to be equal to 414 at priority 1000, and I want your height to be at height 0, which is clearly impossible, but at priority 50. And what the constraint solver of AutoLayout does is that obviously it has to solve it with the width of 414, but it cannot solve the equation that says the height needs to be equal to 0. So instead, what AutoLayout does is that it will minimize the error. So when a layout constraint cannot be satisfied, AutoLayout will always try to minimize the error and therefore be as close as possible to the constant that is being given. And in that case, we say the height needs to be 0, and the solution to that equation, there's only one that is optimal. It's the one where the height is as close as possible to 0, therefore it is the one that is the smallest cell size as possible. And that is how, at least in UITableView, cells are sized. It just tells this method to size itself based on, with a required width and a height that is as close as possible to 0. And AutoLayout will try to minimize the error for that constraint. It's a lot to understand, but once you start overriding that function a lot, you will see and you will really gain insight as to how AutoLayout and self-sizing works in many, many different cases. And it's a great way to debug and troubleshoot what's going on here because you are in the sizing pass. And you can understand here if your constraints have not been set up properly yet, and maybe you have forgotten something before that sizing pass is executed. So a great tip is to always override systemlayoutsize fitting size to see all of the constraints being set on your cell. Okay, so we have that, and my designer came back and say, by the way, I'd love for the cells to be a bit taller, like they're a bit too crunched up, and I'd love them to be a bit taller, so why don't we have a minimum height for each cell? So he told me he'd really want to see a minimum height of 60 points for each cell. So I'm going to add that to my cell. So I'm just going to write height anchor constraint greater than or equal to constant 60. Once again, looks perfectly valid. And I'm going to execute this. And I'm hitting an unsatisfiable constraints problem. So I'm really confused right now. What's going on? Like, it seems that it's perfectly valid to say that my cell height should be more than 60. So let's just disable the breakpoint minimally right now. I'm just going to continue running the app. You can see that nothing has really worked, and that my cells have not really grown in size at all. And so in order to understand that problem, I'm going to use this tool called Reveal, which, yes, it's a shameless promotion. I'm working on that tool. So we're going to use that because Reveal is a great tool that shows you a lot of the constraints and logic that the view debugger might hide from you. So I use this tool a lot because this way it allows me to understand better what's going on. So you can see my app here, exploded cells and all of that. We can see that everything has gone wrong, a lot of red on the left side. And I'm going to look at one of these cells, a Port Adelaide cell. And I can see some constraints here on that cell. So I've got a width of 414, a height of 46.5. So there's a constraint here that is being defined. But I've never defined that constraint myself, right? Like, the cell has been self-sized. And here's my height greater or equal to 60. So in Reveal, there's this great feature where you can inspect any constraint and you got this little inspector showing up. And I can click on that and basically find out what this constraint is about. And Reveal is telling me that this constraint applies the system-defined height of the view because it hosts a layout engine. And in other terms, what it's doing is that UITableView obviously sizes my cell using these temporary constraints injected into my set of equations, right? The width needs to be required at 414 and my height needs to be fitted at height of 0. But if it removes these constraints after that, then my layout becomes again ambiguous, right? The layout path will not be able to really do anything because these equations have been gone away. So what UITableView does is that after the sizing path has been done, it introduces the result of the calculation of the sizing path into the cell and sets that in stone. Say, okay, we have calculated the height and now we are setting that height forever at this height. And so that's what you can see here. Let me go back. And what I can see as well here is that my height greater than 60, greater or equal than 60, is pretty much all alone. I expect to see over constraints. And so why is it all alone in my list, right? I'm at the end of the scrolling area. And if I click on the content view, actually, that's where I see all the rest of my constraints. So I can see everything that's been defined in my storyboard. And that tells me basically that my error is very simple. And it's an error that you may have done multiple times while developing apps, is that actually the sizing pass is not performed on the cell itself. It is always performed on the content view of the cell. And so you should never constrain directly the cell. The cell doesn't participate in the sizing. The cell is just a container. You should not touch it. It's part of the DMZ of things, and you should leave it alone. Only introduce constraint to your content view. That's what gets considered during the sizing pass. So I'm fixing that by just saying my content view's height needs to be equal to 60, and I'm going to run my app again, and let's see if I fix my problem, right? There you go. Now you can see that my rows have definitely grown in size. They look great. So one pro tip, if you ever have that situation, then you might lose hours, right? Like always first maybe check that you have all your constraints defined on the content view and never on the cell directly. Otherwise, this is a layout that doesn't really, that is not really valid. Okay. Okay, and my designer sees that and says, you know what, this is not really working, we don't really need that. So I'm just going to remove that constraint and go back here. So another thing that my designer says that I really want to be able to favorite a team and shout, I really enjoy and I'm a supporter of that team. So why not have a feature where if I click on a row, tap on a row, I really increase the font of that row so that it shouts the name of the team, right? Like, again, like very evolved app, but this is, like I said, a playground. So let me go in my view controller, which is, as you see, very straightforward. I implement really the minimal required to implement all of this. But I'm going to add a function which is, the classic table view did select row at index path. And I'm going to do something very simple. I'm going to first of all deselect the row to make sure there's no highlight. I'm going to fetch the cell for that row, and I'm going to change the label's font to be equal to large title. Everything's pretty straightforward. Once again, there's no bug. It seems pretty fine. So let's run the app again, and let's see what happens if I do this. There you go, still have my app, and if I click on any of the rows, I can see that, yeah, the label size has changed, the label has grown in size. But really, I've got problems here, right? Like Geelong Cat, for example, the G has been clipped. My cell has not resized as I change its contents. So again, what's going on here? I would expect it to just work, right? iOS should be easy to develop for. And oh, that's a joke you're laughing at, I see. So really, like, what I've exposed here is one of the core behaviors of UITableView or any of the container views like UICollectionView is, which is that UITableView is an isolator. It will isolate the views inside itself from the rest of the application. Once a cell has been sized and laid out, you are not allowed to resize it. UITableView will not be aware of any modification of the layout of your cell. There is nothing you can do here. Unfortunately, UITableView and UICollectionView both don't provide an explicit API that would allow you to tell, like, by the way, I would like to resize the cell based on the new layout constraints I've set up. There is no explicit code that you can invoke that allows you to do that. And that's too bad. Like, really, it's iOS 13. We should really have that API by now, but they do not provide that. So there's, first of all, like, my personal rule, for example, in this kind of situations is that anything that affects the layout of a cell should never be directly set on a cell that is already laid out. You should never basically have that code that changes the font while the cell has already been created and configured, for example. But there's another workaround that you may be familiar with, which is in order to tell the table view to still resize its cells, there is a simple trick, and as far as I'm concerned, that is the only trick that exists. And it's really ugly. But we can simply call table view begin updates. table view end updates, which you may have used in order to batch modifications to a table view, right? They're supposed to be used to batch moves and additions and removals, but actually in the end updates code of table view, there's a lot of logic, and one of the pieces of logic is that I'm just going to throw away all the layout information for all my cells, and I'm going to resize everything. It's a bazooka approach to resizing cells dynamically. It's not great, but it's the only thing I can think of. And once again, I'm going to complain that it's 2019, it's iOS 13, and that's the only way we can have that dynamic behavior. So in case you need to dynamically resize the cells as they change their content, and you have directly touched that cell, poked at that cell directly, if you have to do that, then that is a workaround to get cells to be sized again. So I just introduced this, and I'm going to just run my app again. And if I click on one of the rows, you can see now that indeed my cell is resizing as I click the thing, because end updates is resizing the cell, not only the one that I clicked on or tapped on, but every single cell. It's actually a very costly call, so that's why it's not ideal, but at least it makes things behave the way I expect it to be. So everything is working great now, so don't forget that tip. Use begin updates, end updates to just have everything resized. You can even call it without any code in between, right? End updates will be smart enough to figure out that things need to be resized. So that's great, we have that feature done, and then my designer once again looks at the design and says, you know what, these section headers don't look that great, they're just like text, why don't we do something more graphical? And he's right, and I happen to have already a header view written in my code, already registered in my table here, right? So I've done everything that's required to have self-sizing headers in my table view. So I've got an estimated section header height and a section header height set to automatic dimension. There's a lot, obviously, a lot of magic invocation to have self-sizing work, and sometimes it takes a while to find that out, but that's basically what's required to get section headers to self-size. And I'm registering that class, which is my header, and we're going to look at it. And because Storyboard and Interface Builder doesn't have support for header footer views for your table views, this is all defined in code. So you can see my layout, once again, is fairly straightforward. I just have an image view, and I'm pinning it to the top, leading bottom of my header. I make sure to add it to the content view, right? It's the same thing for headers and footers. Always pin your constraints to the content view and not on the view itself. Otherwise, you'll have the same problems. And I'm also constraining my image view to be a specific, specific size, 64 by 50. And I just have to go back in my view controller, and I actually I'm going to comment that out to say I don't want a title, a textual title anymore, but I want a header view now. So once again, very straightforward code. I'm dequeuing that reusable header footer view. I'm setting the image, and I'm returning that. Very, very straightforward code. And I'm going to run this once again. And we should have some nice headers and footers that look really nice. And yeah, like you can see, it looks so much better already. I've got these little state images that indicate geographically where the teams reside. It looks great. I'm ready to ship on the App Store. But then at the last second, I see that on my console, UIKit is still yelling at me, and it's yelling at me with a lot of things, like we have seen this code before, where we kind of start rolling our eyes and we give up on auto layout and we start using other technologies. But I'm trying to understand what's going on here, so even though everything looks fine at first. So let's go back to my header, and let's use our good old trick of overriding system layout size, fitting size. I'm going to do this, and I'm also going to break on UI view alert for unsatisfiable constraints. And let's run the app. My app is running, and first thing I get is I'm hitting that breakpoint, UI view alert for unsatisfiable constraints. But I put a breakpoint in my system layout size fitting size. So what is going on here? So I'll continue. I'll just continue the progression of my app. And by the way, let me look. And And here's the breakpoint now hitting at systemlayoutsize fitting size. And let me look quickly at the console output. I've got something showing up here. This one is really interesting. You can see that it's complaining about a constraint that cannot be satisfied, and there's one which is called UIView encapsulated layout height, which says that the height should be equal to 28. So a constraint that is tagged with that name, that identifier, is basically the constraints I have shown you before. These are the constraints where UITableView sets in stone the size of the header or the cell, right? It has a specific identifier, and that's how it's named. In that case, height to 28 is the default header size for TableView headers. So what is going on here is that UITableView has a bug, and UITableView, once again, I'm going to go back in my rant, but it's 2019. UITableView has a bug where it is laying out my headers before it sizes them. And so it uses the default header size, tries to lay that out, finds it's not satisfiable, yells at me, then eventually sizes my header, and eventually falls back on its feet. And after it yells at me, basically finds the right solution. I'm gonna skip some more, yelling and all of that, and everything finally finds a solution, and everything is sized properly. But we want to avoid the console being full of things because we might miss some problems. So what I'm exposing here, really, there's no solution to that, right? There's UIKit and UITableView has a bug since forever where it does this layout pass before sizing the header, which is fairly shameful, I would say. Really, it's 2019, that should be fixed. So the only workaround I know of, and that I'm using personally to get around that problem of the console filling up with garbage, is to make one of the constraints that really is conflicting not required. So I'm going to remove my bottom constraint here, and I'm going to just take it out, and I'm going to store it here. I'm going to change the priority so that it is not. There you go. It's not easy to type on that stand. There you go. I'm going to make the priority of that constraint not required. So I'm going to take required -1. This way, it's able to break without UIKit being really angry at me. And I'm going to put it back into my set of activated constraints here. So all I've done is taking that constraint out and giving it a different priority than required. Overall, my layout is the same. And let's see how it does now. I'm going to run the app again. There you go. So I've got the same good layout out there, but now at least the console is not yelling at me. Like I said, it's very sad, and that in 2019, after years and years of UITableView, which is a basic construct of UIKit, and every iPhone app, this behavior has still not been fixed. I don't know if some apps rely on that, but I don't understand why. So this is me basically ranting about iOS bugs, and this is one of these self-sizing bugs that you may have encountered, never understood really what was going on and gave up on, but now you maybe hopefully have a better understanding as to what is happening, and you can point the finger at somebody else, which is whatever Apple engineers is working on that code nowadays. Anyway, I've got a little bit of time left, so I'm done with UITableView, and I've got a bit of time left, so I'm just going to introduce you a little bonus feature. So I've shown you UITableView, and now let's quickly talk about UICollectionView. So I'm going to edit my info plist quickly of my app to start using something else for my app. I'm going to change my main storyboard to this one called CollectionView. And we're going to have a different app showing up. You're going to appreciate that. Yep. And I'm going to disable that breakpoint as well, because obviously I'm showing bugs. There you go. This is a collection view of a collection of the best mullets in the AFL history. And I want to know if you have paid attention so far. So if I were to override system layout size, fitting size on a UICollectionView cell, what do you think are the arguments passed to this function? Does anybody have any idea then? If you understand really how self-sizing cells work. Does anybody want to venture a guess? Okay, no? Okay. Not a problem. And So let's open my cell. Oh, I'm going to show you basically how my collection view is set up. Once again, not much code, very straightforward. I'm just, in order to get self-sizing cells to work, I'm just setting, the estimated item size on the collection view flow layout, and I'm using 4242 as my estimated size. Is totally wrong, but it doesn't matter, right? And if we override the cell systemlayoutsize fitting setup, actually no, I just need to use my snippet. Same thing, I call super, I don't change the behavior at all. I'm going to break on that and see really what UI collection view does. And let's see what it passes as its arguments. There you go, my breakpoint has hit. Let's reopen that inspector. And I'm going to zoom in so everybody can see. And we can see here, UI collection view is interesting. The target size that it passes, the target size that it targets, it really desires, is the estimated size I have passed to my flow layout. So by default, it will try to size it to the estimated size you have passed it. And my horizontal fitting priority is equal to 50, and my vertical fitting priority is equal to 50. And that makes perfect sense. UI collection view cells float in space. They have no constraint really on the x-axis, on the y-axis. They get to be sized on their height or width. Any dimension can be floating. So it is saying, I would love to be 42 by 42, but truly any constraint that overrides that is going to push or shrink my content if need be. And that's really what UI collection view does compared to UITableView. It uses these parameters. Now, something else interesting, and that's something that's not necessarily very, so by the way, just to say that, right? If you have self-sizing cells in a UI collection view, make sure that your constraints are always over priority 50. Otherwise, these temporary constraints will overrule your constraints, and you will never get the size that you desire, right? So always make sure to be at least over 50, otherwise these constraints will take over your layout. And now, something interesting. So I'm just going to continue, and there you go. Again, mullets. Everybody appreciates a second serving of mullets. And I'm going to re-break, and I'm going to start scrolling the collection view and see what happens then. I'm scrolling, and look at what hit now. We can see that the target size has changed. It's not 4242, which is my estimated size anymore. It is 200s. And 278. And I cannot explain that behavior. I can understand what's happening is that there's a cell being recycled. That cell used to have a size of 200, 278. But somehow for the sizing of a new cell, once again, instead of passing 4242, which is my estimated size, it just passes whatever size the cell was for another item, a totally unrelated item. And I really cannot understand what UI collection view does here. To me, it sounds like a bug, and it's probably a bug as well. So just to let you know, be mindful that UI collection view also has this problem where as you start scrolling, the target size passed to that function starts fluctuating depending on whatever cell gets recycled. So yeah, very, very weird behavior. And let's see, yep. And yep, and I'm going to stop here, but yeah, like that's basically my talk. I just wanted to show you, self-sizing cells, but also how to use the debugger, breakpoints, inspecting backtraces, and really looking at UIKit methods to understand the behavior of the system. You can glean a lot of information by just looking at the name of the methods being invoked, or by overriding some specific functions and introspecting what's being passed at any point, and really trying to analyze and understand the sequence of calls that lead to a result. And this way you will be able to troubleshoot your app, and maybe also be able to really be sure that a system is buggy or if it's your problem or not. So so don't hesitate to use breakpoints and all of these tools at your disposal, because that's how you get to great iOS apps. Yeah, thank you.